In the last video, we were able to explain what a linear system was, which was a set of two or more linear equations. This was an example of a linear system. We also described what it meant to solve a linear system, which was to find a point of intersection. And these three were the methods that were outlined in grade 10 that we were to discuss: graphing, substitution, and elimination. In today's video, we will introduce method 2, which is substitution. Now, I've outlined a series of steps for substitution. Step 1 in the process, after being given two equations, Step 1 in the process is to ask yourself, are any of the variables isolated? Now, what does this mean? It means a letter is alone on one side of the equation. So in this case, with this example, the answer to that question in step 1 would be yes. I have y equals 2x plus 3. I have a letter, in this case, y, on one side of the equation, and the rest of the junk on the other side. So the answer to step 1 would be yes, in the example that I gave from the previous video. So if the answer is yes, if so, go to step 3. Step 3 would then be to substitute this variable into the second equation and solve for a letter. So what I would do is I would take these contents. See, this equation is saying y is 2x plus 3. So I take 2x plus 3 and I would substitute that information in for y. And I'm going to show you in an example how to do this. Now, if a variable wasn't isolated, meaning a letter wasn't on one side, then I would have to proceed to step 2 instead of jumping to step 3. And in step 2, no surprise, I would have to isolate for a variable, meaning I would have to figure out a way to put one letter on one side and the rest of the junk on the other side for one of the equations. And when I say pick the easiest, what I mean is pick the easiest letter to isolate for. And I'll explain what that means. Once you've substituted this variable into the second equation and solved for a letter, substitute this letter, whatever you get, back into the first equation to get the last letter. And then I would find two letters, x and y, and I would find the point of intersection, and I'd be done the problem, at which point I would probably have to check my solution. So let's run through an example and look at the step-by-step process, because it's going to be the same no matter what. In this case, I have an example. Y equals 2x plus 3 and x plus y minus 3 equals 0. Note, this is the very same example of my first video, what is a linear system? So step 1, ask yourself, are there any variables isolated? We've already answered this. Step 1, check. Y equals 2x plus 3. Great. Now, if so, we can jump to step 3. Substitute this variable into the second equation. So I take y equals 2x plus 3. I take its contents and replace y with 2x plus 3. Then I collect like terms. And here, all I have to do, since there's a plus over there, means I can drop these brackets. Note that if I don't have a sign in front of 2, that means the sign is plus. A plus and a plus make a plus, so I have x plus 2x. Likewise, a plus and a plus make a plus, so I get plus 3. Now I can collect my like terms. 1x plus 2x equals 3x. Positive 3 minus 3 equals 0. And I get that equal to 0. Nothing changes on the right side. Notice how my equal signs are also lined up. Then I've got 3x equal to 0. All I have to do is divide both sides by 3, and I found x equals 0. So that's the end of step 3. Because it says substitute this variable, in this case y equals 2x plus 3, into the second equation and solve for a letter. meaning find a value of one of the letters. In this case, x is 0. Step 4 is substitute this letter, the one that you just found, back into the first equation to get the last letter. So we substituted this into what is the second equation, and we found x equal to 0. I take this now, and I substitute it back into the original equation, the first equation, to find my last letter. So that's step 4. Substitute x equals 0 into y equals 2x plus 3. So I do that. I replace x with 0. And I get 2 times 0, which is 0, plus 3, and I get y equals 3. Now, remember this, because this point is crucial. After I finish step 4, an optional step would be to check my solution. To check your solution means to substitute this x value and this y value into both original equations. If I can prove that left side equals right side for both equations, my solution that I found is absolutely correct. So that's precisely what I'm going to do. I'm going to substitute x equals 0, y equals 3 into the first equation and the second equation. So I do that side by side. I punch in y equals 3. Great. I punch in x equals 0. Great. I get 2 times 0, 0, plus 3 equals 3. And over on the left side, I already had 3, so I get left side equals right side. Great. Next, punch in x equals 0, y equals 3. And likewise, I get 0 equals 0, left side equals right side. Therefore, the solution is x equals 0, y equals 3. And I've written this in terms of an ordered pair, meaning an x value, comma, a y value. That's the solution to the first example. Now, in this case, I had one of my equations isolated for a variable, y equals 2x plus 3. What if I don't? What if I have both equations that aren't isolated? That's example 2. See, in the first equation, I've got standard form, and this is pretty close to standard form. So step 1, ask yourself, are any of the variables isolated? No, none of them are. I don't have any of the letters on their own. So step 2, isolate for a variable and pick the easiest letter to isolate for. Now what that means in this case, when I say easiest, what that means is pick a letter that hopefully has a small number in front of it, the smallest that you can find. Now here I've got 2, negative 2 in front of the x's. Here I've got 1 in front of the y, and I've got 2 in front of the y. It's much easier to isolate for y, and in fact, it's much easier to isolate for y in the first equation. So that's precisely what I'm going to do. In this case, I move 2x and 5 over, or what I'm really doing is I'm subtracting both sides by 2x and subtracting both sides by 5. And I end up getting y equals negative 2x minus 5. Remember, that's using the first equation. I haven't really used the second equation just yet. So now, step 2, check. Got it. Step 3, substitute this variable now into the second equation and solve for a letter. So I'm going to take these contents, and in step 3, I'm going to substitute into the second equation, the one I haven't used just yet. I'm going to substitute or replace y with this whole thing, and please do not forget to put brackets. It's very important. So now, what I do is I expand this 2 into both terms. I get 2 times negative 2, that's negative 4x. 2 times negative 5, negative 10. So I get negative 2x minus 4x minus 10 equals 12. And now all I have to do is isolate for x. So I move the 10 over, or I add 10 to both sides. And I collect like terms here with the x's, and I get negative 6x. So negative 6x equals 12 plus 10, which is 22. If I divide now both sides by negative 6, I'll end up getting negative 11 over 3 after reducing the fraction. So now I have this x value. I'm done step 3. Step 4, substitute this letter, the letter that you just found, in this case x, substitute this letter into the first equation and get the last letter. So I'm going to take this x value and I'm going to substitute it into the first equation, okay? And this has been modified to give me this equation. I'm going to substitute into this. Because if I substitute x into here, I've got an equation for y. This is perfect. So I substitute this x value. X equals negative 11 over 3. Negative 2 can be written as negative 2 over 1. So if I multiply this fraction across, I get two negatives making a positive. 2 times 11 is 22. 1 on the bottom times the 3 is 3, so I get 22 over 3 minus 5. If I were to put this under a common denominator, this would be 22 over 3 minus 15 over 3, because 15 over 3 is 5 over 1. 22 minus 15 is 7, so I get 7 over 3. So y in this case is 7 over 3. Now we jump to the optional step 5. The optional step 5 is to check my solution. So I substitute, and don't worry about the scribbling mark here, I just made a mistake. Optional step 5 is to substitute x equals negative 11 over 3 and y equals 7 over 3 into both the original equations. So I do that. Punch it into here, punch it into there. And I do it side by side. So I substitute negative 11 over 3 into x and 7 over 3 into y. After I collect like terms, after I put it all under a common denominator, add them up, I get 0 equals 0 on the left side equals right side. On the right, I likewise get 12 equals 12, left side equals right side. Perfect. This method and these series of steps are exactly how you'd solve any question, any linear system, by substitution. It's a process. Ask yourself, are any variables isolated? If not, isolate for a variable. If they already come isolated, substitute this variable into the other equation and solve for a letter. Now take this letter, punch it into the other equation which you haven't used yet, and find the last letter. Or into the first equation, and find the last letter. Then check your solution. And then you're done. That, ladies and gentlemen, is substitution. Thank you for watching, and in the next video, we will be talking about the method of elimination.